Okay, welcome back. Hononegah, Honors Algebra 2. We're going to move on to section 9.5. So in section 9.4, we did nothing but sine and cosine. And so now we're going to talk about nothing but the other trig functions, tangent, cotangent, secant, and cosecant. So let's start with tangent and cotangent because they're kind of their own entity. And they get a little bit challenging to graph. But here we go. Graphs of tangent and cotangent curves are related to the parent function. And you'll notice there's some undefines in here. So tangent, undefined, and undefined. So what that means is that there's locations in the graph that you get an asymptote. And so you're going to have to understand that there's an asymptote involved. Also that the period length is no longer 2 pi. So again, there's some subtleties of tangent and cotangent that we're going to need to understand here. Here's what the picture of cotangent and tangent look like. Tangent and cotangent now have a period length of pi. So that is important to understand that we're no longer doing 2 pi for a period length. We are now doing pi for a period length. Also, and this is something you're just going to have to kind of memorize, tangent goes from low to high. So as it goes along the asymptotes, it starts low and goes high from left to right. Cotangent then goes the opposite direction, starts high and goes low. And notice that it crosses the midline in the middle. So in between the asymptotes, it will cross the midline. So cotangent goes high to low, tangent goes low to high. So as we're graphing this, you'll also notice that you still are going to have a midline that you're going to have to put increments in. So that stuff hasn't changed when doing tangent and cotangent. So the domain is no longer, the domain is all real numbers. So all real numbers. However, there are increments or odd multiples of pi over 2 that the x values can't have. So there's vertical asymptotes there. And we'll get into more of that. This is more of the technical definition. Okay, we'll get more into that probably as we do the graph because it'll make more sense as we go here. But this is the technical definition of the characteristics of tangent and cotangent. All right. The graphs of y equals a tangent of bx. So again, you're putting a number in front and you're putting a number in front here. Just like before, changes the amplitude and period length. Now, to be technical about it, the amplitude does not actually occur because it goes above and below. So there really isn't an amplitude, but it will affect the characteristics of the graph. Like it'll stretch it. It just will be hard to actually see that. Period length, however, and I know it's hard to read because my handwriting got really bad there, but the period length is very important for us to understand. Remember, a period for this is basically pi, and you're taking pi divided by b. So instead of a 2 pi like you did in sine and cosine, we're now going to divide pi by b. All right, here we go. The beginning is going to be exactly the same as what you did before. You are going to draw in a midline. And I still want you to do the tick mark right in the middle. And I still actually want you to do 4 to the right and 4 to the left just to be consistent with everything else that we were doing before. So again, just to give us a nice pretty picture going across, we'll still do 4 tick marks to the right and 4 tick marks to the left. Okay, period. Period length is pi divided by b. So in this case, b is 2. So the period length is pi over 2. Increments. Now, instead of dividing by 4, okay, and I understand there's 4 tick marks, but instead of dividing by 4, we're actually going to take the period length divided by 2. So the increments is pi over 4. So again, you are changing, because you started off with a period length of pi, you're only talking about 2 quadrants. So 2 quadrants, so that means I need to divide by 2. When I did 2 pi as a period length, I divided by 4. So that probably wasn't a very good explanation before. So the increments in this case is pi over 4. There's no shift, so 0 is where we're going to start in the middle. You're going to go adding pi over 4 each time to the right. Pi over, 3 pi over 4 and 4 pi over 4. Subtracting pi over 4. Okay. Now, here's what I would have to tell you. Where in the world are your asymptotes going to be located? And here's what I tell everybody. Here's how I do it. And I know this is not how everybody else does it. Tangent is sine over cosine. So the underlying curve, or the curve that is on the bottom of the fraction, you need to draw the dots for. So draw the cosine curve, dots only. So dots for a cosine curve, and I make this really small, would be off the midline. And so here's what happens. Every time the underlying curve hits the midline, it causes an asymptote. So every time the underlying curve, so again, the underlying curve for tangent is cosine, hits the midline, causes an asymptote. And so now here's the finale. Here's the tangent graph. Tangent graphs start low, go through the midline, end high. Low, through the midline, high. Low, through the midline, high. And notice it doesn't actually cross any of the asymptotes. The last thing is the 3 out in front. Nothing is being added or subtracted, so 0 is the midline. And just to give you a point of reference, this would go up to 3 and down to -3. Again, there is no amplitude with tangent because it goes above that and it goes below that. Describe. Okay, so now we have a transformation describe here. The 3 is a vertical stretch by 3, and the 2 is a horizontal shrink by a half. Again, just like we did before, always draw in where the y-axis would be located, so through the 0, and that is a tangent curve. Cotangent. Start with your midline. Draw a tick mark in the middle. 1, 2, 3, 4 tick marks to the right. 1, 2, 3, 4 tick marks to the left, just to be consistent. Again, some people, when they graph these, only go 2 to the right and 2 to the left because ultimately the period length is smaller. So the period length is pi divided by b. So in this case, the period length is 2 pi. Increments. Instead of dividing by 4, you divide by 2. So it starts at 0. There is no phase shift. And you're going to add pi to the right and subtract pi to the left. The cotangent. Cotangent is cosine over sine. So the underlying curve is sine, the curve on the bottom. So I'm going to draw in dots on the axis off, on, off, on, off, on. Every time the underlying curve hits the midline, it creates an asymptote. The reason it creates an asymptote is because you're dividing by 0. This goes back to when we did vertical asymptotes back in a previous chapter, rational expressions. Cotangent. Cotangent goes from high to low through the midline. High to low through the midline. Whoops, I missed the midline on that one there. There we go. Describing. The midline is at 0 because there is no nothing being added or subtracted to the function. It goes up and down 1 because there's nothing being multiplied with the function. And always draw in the y-axis so you know where it's located. Describe now. All right, so the only thing that happened was this number right here. So you're talking about a horizontal stretch by 2. Secant and cosecant. again, you have to understand that secant is 1 over cosine, and cosecant is 1 over sine. So there's an underlying curve. The cosine curve is what we'll use as our underlying curve for secant. Sine is the underlying curve that we'll use for cosecant. So as we are graphing this, you'll notice in the first graph here, there's a sine curve. I don't actually make the sine curve. I merely put the dots for the sine curve, or the cosine curve, sorry. And again, notice every time that it hits an axis, they drew in an asymptote. And instead of, it's reciprocal, so instead of the graph going towards the midline, it's actually going away from the midline. So it looks like a bunch of parabolas. So it touches the underlying curve and goes in the opposite direction. Period length, we're back to 2 pi again. Okay, so we're back to dividing by 4 when we do our increments. So again, tangent and cotangent is the only time you have pi. And instead of the increments being divided by 4, the increments are divided by 2. All right, so again, this is the technical characteristics of a secant and cosecant curve. Again, amplitude doesn't really occur here, but when you multiply by a value, it does change how high and how low the parabola actually goes, or the curve goes. So here we go, running through this. First, draw on a midline. Middle. 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. That is the case for every single trig function I ask you to graph. There is nothing being added or subtracted. There's no parentheses with x, so we're talking about 0 being the middle. Period length. Period length for a secant curve is 2 pi divided by b. So in this case, there is nothing being multiplied with the x. Increments. Period length divided by 4. So that's what you're going to add to the right and add to the left. So here we go. If I add pi over 2, add pi over 2, add pi over 2, and add pi over 2. Going the other way, you're going to subtract pi over 2. Next, we're talking about a secant curve. All right, secant is 1 over cosine. So I have to draw in a cosine curve. Just put the dots of a cosine curve. Notice that cosine curves start off the midline. Every single time the cosine curve touches the midline, draw in an asymptote. So you'll notice that this lesson is all about asymptotes. Next, instead of going towards the midline, you're actually going to go away from the midline. So see how this dot right here, I drew a parabola away from the midline. So a parabola away from the midline. It's not technically a parabola, but that's what it looks like, so that's how I describe it. So a parabola away from the midline. That is a secant curve. Now, describe the midline. The midline, there's nothing being added or subtracted at the end. So the midline is at 0. The 3 means it goes up 3 and down 3 from the midline. Draw in the y-axis. It's always the last thing I do. Describe the transformation. All right, so the only thing that happened is the 3 that's out in front. So that is a vertical stretch by 3. We'll keep continuing here. Draw in a midline. Tick mark in the middle. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Notice that does not change. There is no phase shift, so there's nothing being added or subtracted. Tomorrow we'll start doing phase shifts again. Period length. Period length is always 2 pi divided by b. So in this case, the period length is 2 because the b value, there is something being multiplied with x. Increments. Increments in this case is always period length divided by 4. So I'm going to add a half each time. So adding a half, adding a half, subtracting a half. Sorry, 2. Cosecant. Cosecant is 1 over sine. So the underlying curve is a sine curve. So I'm going to draw in, so it starts on the midline, a sine curve. Oops. That dot is incorrect. I'll erase it in a second. This one is not supposed to be there. Now, notice I didn't actually draw in the sine curve because the sine curve creates the asymptote. And then the amplitude of the sine curve is where I draw in my up and down parabolas. And they're not parabolas, so understand that, but that's where I draw in the actual curves going away from the midline. Midline is at 0, and it will be on all of your lesson for today because there's nothing being added or subtracted. And the amplitude, or how high and how low the dots are located, is up and down a half. So describing this transformation, we got a vertical shrink by a half. And then we got a horizontal shrink by pi. Homework assignment is out of the book. I'm sure Ms. Kinsel will probably turn this into a worksheet so that you don't have to do it that way. You don't have to actually get your book out. I'm not sure how she'll do that. If you have any questions, make sure you ask. This can be very challenging. Good luck, and I hope all of you are being safe.